1, 1. That's what it does. Like it just takes forever to get the Wi-Fi, so it counts down. Like you're like, I know you're not gonna give me one. All right, all that can go on your calculator. What do you get? You get a squared equals what? Oh, that's not right.
I got 16.864, but I have no idea if that's right.
16.862 is what I got. I got that. So it's close enough. Take the square root. So A is 4.106 miles. Am I done with this question? No. Have I even answered this question? No. I just did the stuff I needed to do to answer the question. So if that's 4 miles, it says how far did they hike in all? So they started campsite A, and they went 30 degrees west to a waterfall located at B, and then they went to an old Indian burial ground at C, and then they went back up to 8 miles up back to the campsite, whatever. So how far did they go in all?
Like 18. Do you have to put the decimal on it?
Yeah. So the waterfall's at B. So we're trying to find B. And it says, okay, so when they left B, what was that angle right there? And it says use law of sines. What page can I find law of sines? 548 is law of sines. Coffee is hot. Okay, so law of sines would be the sine of A is to A as the sine of B.
Do you care what?
No, she was in the last class.
Oh, I'm sorry. Okay, bye-bye.
Bye. Interrupting classes is not comical. Cross multiply. Divide. What is B? What is angle B? Do I know yet? I know. I push buttons. What? I didn't get 60. I didn't get 60. Did somebody else get 60? Hang on. 8 times the sine of 30. Divided by 4.106. Oh, wrong button. 6. And then I want the inverse sine of that. I got 76.953 degrees.
So did I.
So let me show you what I did. Okay, let me show you what I did. So I multiplied these two. Who's the last one in?
You were.
No! You were!
No, I walked out there to talk to you, but you walked in
I
behind me.
swear it's Alan's good homework.
Is it Alan?
Hey, Alan. What?
I left my baseball bag in here.
I don't care.
So
We're having freak out here, trying to do some math and stuff. All right, so I multiplied these two. 8 times the sine of 30. Okay, and that equals the sine of B times 4.106. So I divided by 4.106. And I got that, right? So the sine of B equals 0.974. That's what the sine equals. So then I did the inverse sine of this 0.974, and that gave me B. So second sign of my answer, and 76.953 degrees. Don't forget your degrees or you'll lose a point. Nobody has like points to spare. At least I don't think you do. Some of you might. Who knows? All right. Are we ready for the unit circle? I am. Mhm.
First thing when I opened it up too was these.
Awesome. All right. On the blanks inside the circle, write the degree measure of the angle theta, where theta is between 0 and 360, that would terminate at each notch. Okay, so this would be 360 degrees because we're actually not starting with 0. See, 0 is not included. So if I went up to here, that would be 30 degrees. What would this one be? It's like halfway. 45. This one would be 60. How many degrees is this? 90. How many degrees is this? Yeah. How many degrees is this one? 135. 150. And then 180. Yes. 210. 225. 240. And this one? 70. How about this one? No, 300.
Good job.
315. My favorite time of day. And then this one? 330. All right. Okay. So those are your degrees, right? Notice that every angle on the unit circle is a multiple of either 45 degrees or 30 degrees. In the space below, convert these 2 degree measures into radian measures. So 45 degrees into radians would be how many? Pi over 4. Because 45 goes into 180 4 times. And then 30 degrees into radians would be how many times is 30 going to 180?
6.
So it would be pi over 6. I only watched the first 2 minutes. Really was. And we had to do it twice because I messed up the first time.
Yeah, Hunter was only 35 minutes long.
It's only 45 minutes. She has to be joking.
You said we don't stall for 10 minutes each day?
Come on. All right, now on the blanks outside the circle, write the radian measure, whose each angle theta from 0 to 2 pi. So 30 degrees would be what?
Pi over
45 is pi over 4,
160 degrees is 2 powers.
which would reduce to pi over 3.
I know. Pi over 2.
Pi over 2. Mm-hmm.
And then you just kind of start over, like 7 pi over 6.
That's not 7 pi over 6.
2 pi over 3.
2 pi over 3.
Oh, got it.
And then what about this one? No, it's 3 pi over 4. Because 45 goes into 135 3 times. 150. 5 pi over 6, right? How about 180?
5.
Yes.
Can I say my number now?
Yes.
7 pi over 6.
210 is 7 pi over 6. You are correct.
Now you can. 5 pi over
5 pi over 4.
and then 4 pi over 3.
Mm-hmm.
You just add the denominator on the other side.
How about 270?
3 over 2. 3 pi over 2.
$300.
5 pi over 3.
5 pi over 3.
7 pi over 4. 11 pi over 6.
2 pi.
No, it's easy.
All right, you got that? Okay. Now, on the inside, go through and write those radian measures again. On the inside.
So we just flip it?
So you're going to write all your radian measures. It'll help you memorize them.
I don't know the first one. The second one. This one had fun. Yo, how first time I was in. I don't know.
What? You talking to me? You talking about me? Watch yourself. Mute this video. Tell you how it is. All right. Did everybody got the inside of their unit circle filled in? Or do I need to wait a second? Okay, because we're finna do some real math. Like mathy math. You're gonna make some people cry. You got your game face on?
Dude, chocolate pie is the best kind of pie.
It is, actually.
What
It's
about
probably my favorite.
Mr. Fazoli's coconut cream pie?
Okay, according to the announcement that I got this morning, we will be in this class for a minute tomorrow. So if you want to do some Pi Day stuff, you can. It has to be circular, has to be enough to share. Bring your own drinks. You're not bringing 2 liters in cups because that's just a big old mess and that's not happening. So, and if not, if we are not in this class tomorrow, then you get to take home a whole pack of Oreos to eat over spring break all by yourself. So how about that?
I'm an Oreo. Telling you, my brother.
Anyway, I'm glad that's on video. Okay, so at this point, what we're going to do now is we want to know the coordinates of the points on the unit circle. See, these are points right here. That's a point. That's a point. That's a point. So we want to know these coordinates, okay? So we're going to use the definition of the unit circle, a circle whose radius is 1, and then we're going to use what we know about special right triangles, okay?
I told us this last year.
I-
I hated it.
I did tell you last year,
Remember?
and it was
No.
fantastic.
Put signs in the circle,
So,
yeah. You lose. Because the hypotenuse is 1. See, you do that thing, like, do square root of 3.
Once you know, like, 4 or whatever, can't you just like flip it around some and change signs?
once you know, like once we identify 2 angles, you're done.
Okay.
You just have to change signs. So this is 45, okay? So we're looking at a 45, 45, 90 triangle right here within the unit circle. That's a radius of 1. It's 45 degrees. It's 45, 45, 90. If it's a radius of 1, okay, R1, then how long is this side right here?
Oh, no.
There's how many pages I got?
Okay, remember your rules for 45, 45, 90s.
No.
This is x and this is x. This is x times the square root of 2.
So 1 divided by the square root of 2.
So right now, yeah, we're saying that 1 is equal to x times the square root of 2. So I divide by the square root of 2. I'm going to tell you, in calculus,
listen.
you can keep it like this. You haven't made it to calculus yet. So this is the square root of 2 over 2. So that side length right here is the square root of 2 over 2. What's this side length?
Square root of 2 over 2.
Square root of 2 over 2 because they're equal.
X.
So this point right here on the unit circle, how far did I go over to get to that point? Square root of 2 over 2. How far did I go up to get to that point? Oops.
You just went straight line through it, bro. Oh.
So that point right there is the point. Square root of 2 over 2. Square root of 2 over 2. That's what that point right there is.
Did we have to do this one more? Like we had to like finish it, didn't we?
Probably. I don't know.
You don't have the square root of 2 over 2?
Jerk.
All right. So let's look at this one. This is still 1. This is 30 degrees. So let's remember, I guess I should really do this on the screen so Alex can see it. Yeah. Come to school next time, dude. Do you remember your relationship for a 30, 60, 90?
2 times square root of 3. 3 times square root of 2.
Okay, so if this is A, this is 2A, and this is A times the square root of 3. All right, so if this is 1, then what's A?
1
1 half. Okay. And then what's this side?
1/2 times square root.
Which is the square root of 3 over 2. So for this particular problem right here, how far did I go over?
Square root of 3 over 2.
And how far did I go up?
1/2.
So this point would be square root of 3 over 2, comma 1/2. So this is that's that point. Now what's going to happen with 60? If I drew a 60-degree angle,
It's the same thing. But
how far did I go over on the 60? A half. And how far did I go up?
square root of 3 over 2.
Okay. If this is the unit circle, what's this point right here?
What one?
Point
0.01.
01.
Oh, I thought they how far away it was. Doing it.
Okay. Just lots of people are writing. I don't know if you're getting ahead or if you are waiting or catching up. So these two angles here and here have the exact same reference angle, right? I'm going over the same amount to get to that point, and I'm going up the same amount to get to that point. Except, which direction am I going over on this one? Left, which means this is a negative 1/2. Is it still a positive square root 3/2?
Yes.
Okay. These two are the exact same reference point or reference angle. They both, they're both 45, 45, 90s. So what point is this? It's just going off to the left. Okay. How about this one? What's this one going to be? What is this point?
Negative 1.
Mm-hmm. What's this point?
Negative 1/2 square root 3/2.
Other way around.
Negative square root.
Yes. Because it is the same as this. It's still 30 degrees away from the reference angle is 30 degrees. So it's still going to be the same. It's just everything's negative. How about this one? Mm-hmm. Can you finish it? All right. All right, so let's look at our trig ratios and our right triangle definition. Instead of looking at them as right triangles, let's look at them in terms of circular angle trig. So if I'm here at theta, in a right triangle, sine is what over what?
Opposite over adjacent.
Opposite over hypotenuse?
It's been rough. Bad.
Now, the new circular definition in our unit circle, opposite theta is this side right here. And what measurement in all three of these is represented with this right here? You got three choices, R, X, or Y. What's this?
Why?
Y. And what is the hypotenuse from here? R. So our new circular definition, circular angle definition for sine is y over r. Cosine is old way, adjacent over hypotenuse. What's the new way going to be? X over r. Tangent was, now it's y over x. Cosecant used to be hypotenuse over opposite. Now we're going to say r over y. Secant used to be hypotenuse over adjacent, and now we're going to say r over x. And cotangent was adjacent over opposite, and now it is x over y. All right, so we're going to use our unit circle, and we're going to find these exact values. So the sine of 3 pi over 4. Here's 3 pi over 4. And sine is y over r. So that would be y over r is the square root of 2 over 2 over 1. That's easy. Thanks, unit circle. It's just going to be the square root of 2 over 2. You still hate me? They were good cookies too. That's tragic. All right, cosine plus sine. So cosine is x over r. And sine is y over r. So the cosine of 3 pi over 4. 3 pi over 4. And that's cosine. So that's going to be a negative square root of 2 over 2. Plus the sine of 7 pi over 4. So the sine of 7 pi over 4 would be, do we know? Negative square root of 2 over 2. So I have, no, I have 2 negative square root 2 over 2. And those 2's cancel, so I just have a negative square root of 2. Okay, tangent, pi over 6. Pi is y over x. So for pi over 6, what's y? And x is 3 over 2. So you got to flip and multiply. You get 1 over the square root of 3. I'll let you keep that. You can keep that for now.
So on the circle, we have square root of 2 over square root of 2. Is that one?
Square root of 2 over 2.
Over square root of 2.
It's not.
Where do we have that on the circle?
That's what I have on my circle, so is that wrong?
Yeah, that's right. I don't have that anywhere on my circle.
Okay,
It's just the square root of 2 over 2.
okay, so I thought, because it was like 2.5.
Yeah.
That's one.
Yes.
I know that.
That is 1.
Got
Yes.
nothing else wrong today. Zero in the two.
Try tangent of 7 pi over 6.
Okay, I can do this one.
What's the tangent of 7 pi over 6? Do you know? Tangent's y over x. What's y for 7 pi over 6? Negative 1/2. What's x for 7 pi over 6? Well, I've seen this before. It's going to work out like that. It's going to be 1 over the square root of 3. How about secant for 11 pi over 6? Try that one. What's secant? What over what?
All over it.
So that's going to be 1 over, what is x for 11 pi over 6? Yeah, what's that?
33 over 2.
33 over 2.
When I said it's here.
Okay, hold this, sneeze. All right. Which would be 2 over the square root of 3. What happens over here? Let's look at this one. Cosecant of basically 2 pi plus the tangent of 5 pi over 4. Cosecant is r over y. Why are we uh-ohing? Tangent is y over x. What's r for 2 pi?
1.
What's y for 2 pi? Can I do that? Is that allowed?
Probably in your twisted demonic pathway.
No, this is undefined. Division by 0 is undefined. Why are you going to guess?
No, I did it.
So if you want to bring like yummy stuff tomorrow, you can bring it. Somebody better bring plates or spoons or something like that, or you're just gonna be holding stuff in your hand.
Are you gonna bring the
circle food with our
I'm not bringing anything. I'm not bringing anything. You can bring any shaped silverware that you need to bring.
I think I'm gonna bring some lifesavers gummies.
Is this right?